We'll finish this module by further exploring linear regression, one of the most fundamental machine learning techniques in predictive modeling. It helps us understand the relationship between one or more input features, independent variables, and a continuous target output variable, a dependent variable. The simplest form is linear regression, involving a single feature or individual measurable. Multiple linear regression involves two or more features. The core idea of linear regression is to find the best fitting straight line through the data points, known as the regression line, described by this equation where y is the predicted value, b0 is the y-intercept, b1 is the slope of the line, and x is the input feature. The slope b1 represents how much the target variable changes for a 1 unit change in the feature, while b0 is the value of y when x is 0. Yes, to really understand machine learning and AI, you have to know a bit of math. It doesn't have to act as a block, though, and if you don't understand all of the math behind how models are trained, you can still train them effectively. In multiple linear regression, this equation expands to include more features. To fit a simpler linear regression model, we need to find the values of b0 and b1 that minimize the difference between the predicted values and the actual data points. This difference is measured using something called mean squared error, or MSE. MSE is the average of the squared differences, or error, between the predicted and actual values. Minimizing MSE involves finding the coefficients b0, the y-intercept, and b1, the slope, for the straight line that gives the smallest level of overall error. Let's think about an example. Suppose we have a dataset with information on house sizes and their prices. By fitting a regression line to the dataset, we can predict the price of a house based on its size. This sort of task is common in machine learning. After creating our model, it's crucial to evaluate its performance. One way to do this is to use the R-squared value, which indicates the proportion of the variance in the dependent variable that is attributable to the independent variables. Values closer to 1 imply better fits for the model. The coefficients of the regression line also help us to understand the relationship between each feature and the target variable. If the coefficient for house size is positive, it means that as house size increases, so does the price. Throughout this, we must always remain aware of the limitations of whatever method we are using. Linear regression assumes that the relationship between features and the target variable is indeed linear. It can also be sensitive to, that is, can be distorted by outliers. This example is actually quite similar to the skills section task we've set you. You can apply linear regression to different datasets, exploring how changes in features impact the target variable. Some of the visualizations can be useful for human interpretation, but we will also show you how to make a prediction.